All right, so here we're going to take a look at some special cases. Notice on this equation, it's a very short, simple equation. Graph the equation y equals 4. And so immediately you might start off like we've been doing. Let's say we pick 2, but then right away we'd get stuck. Okay, and the question hopefully that's going through your head is, well, if I pick my input number of 2, where do I input it? There's no value for x, so I don't know where to put this number in the equation. Okay, well, the nice thing about this is when you see a special situation like this where it's just y equals 4 with no input value for no input spot for x, what they're telling you is that the input number doesn't matter. That you can input 2, and it doesn't matter what the calculations are, that this particular function is going to always spit out 4 as the y output number. I can pick 0. Okay, and once again, it doesn't matter what the calculations are, is that if I put x is 0, y is set. Y is again going to be 4. Okay, so that's how you should interpret a problem like this, is that no matter what your input number is, it could be negative 100, that the output number is still going to be 4. Okay, so you can keep doing this forever, but no matter what, you're always going to get an output number of y equals 4. Okay, so when you graph it, you're going to get a very special case. We're going to get 2, 4 right here, 0, 4 is right there, negative 104 is off my page, negative 3, 4 is right here. And eventually what we would discover is that we're still going to get a line, but this particular line is going to go horizontally across. It's never going to change in height or level. It's just going to stay a flat line going horizontally across at y equals 4. All right, so that's a special scenario to be aware of. What do you do when that input position is missing from your equation? Okay, which is somewhat similar to this example. Take a look at this one. Now this one doesn't even have y in it. This one says graph the equation x equals negative 3. Okay, so this one is similar to the last one, but not quite the same. What this one is saying is that you don't get a choice in the input number. The input number x always has to be negative 3. Now, like the other example though, there are no calculations to do here. Is if you put an input number of negative 3, y is just going to be whatever you want it to be. So in this case, what you do is you make x negative 3, and then you just get to randomly pick something for y. Let's say 7. Okay, once again though, the next one, x cannot be anything else. X has to be equal to negative 3, but y can be whatever you want. Let's say 0. X is negative 3, y is negative 5. Okay, so every time what this is saying is the x value is always going to be negative 3, and the y value is always going to be whatever you want it to be. Okay, which is, again, related to, but different from this one. This one, x was whatever you wanted it to be, but y was always forced to be 4. This one, x, is being forced to be a particular number, and y can be whatever you want it to be. All right, so now we graph these, negative 3, 7, negative 3, 0, and negative 3, 5. Okay, so not only is our work a little bit different, but notice the pattern we get. If we kept going, we would get a line of dots, but this time a line of dots that go vertically. So everywhere that x is negative 3, there would be a dot. So here we get a vertical line as opposed to this other one where we got a horizontal line. All right, so these are two special cases that I would keep in mind because they do come up now and again, and we need to understand how to handle these special circumstances.